In this video, enumerate with list comprehensions. Enumerate is a built-in function and is super useful for indexing when it comes to list comprehensions. So let's get into it. So let's start by reviewing what enumerate does. So we have our enumerate built-in function and we can pass any iterable to this. So in this case, I'll just pass hey because a string is an iterable and we return our enumerate object. And then next, we could wrap either a list or a dict around this, and you'll kind of get the feel for what enumerate does. So you see how it has created these numbers, 0, 1, 2, and if we made the string longer, we said, hey Python, we're getting a whole bunch more numbers. And what if instead of list, we used, say, dict, we would be creating a dictionary of key value pairs where the key is the number, the index, and then the value comes from the string. So that's what enumerate does in a nutshell. Now let's look at enumerate in a looping context, in an iterating context. So we could do something like for I in enumerate hey. And we can do this and print it out, and I'll show you something interesting. And that's that it did all the work for us. And what I mean by that is there's another way you could have done this, where you did I and then specifically call out a second value here. So basically the index and the value are kind of explicitly written out. And so we could do print I, and when we run this, we're only getting the index because we've only printed the I from this IV pair. So if we did this again with print I, and I think I might need to do a new line. We'll just do that anyway. We'll do print v, and I'll make the v a little more explicit. So you can see that we've kind of targeted our index and our values separately. So basically what I'm just trying to point out is that you could either do it in a way where you're pointing out the index and the value separately, or you could just do it together. And when you do it together, you by default get a tuple. And I want to run that one more time to just show you the type that you get here. So we're only doing it with one value, and when we print that, we're going to get a tuple. So by default, if you're only asking for that one, then you're going to get a tuple. So this is going to come into context. This is going to make more sense when we start with a list comprehension. So let's just say I for I in enumerate hey. And so this is exactly what we were doing before. We're getting our tuple pairs, we have our index and we have our value here. And we're only passing I, we're only passing one thing, and we're getting a tuple out of it. And now we could do that second example I showed you where we did IV. And when we do that, we get the exact same thing, but we're being more explicit about it. And I think this is the way that you're going to see a little bit more often. This way, this first way with only the I, that's kind of like more of just a trick, something to show you. And of course, it doesn't need to be I. So you could be explicit and call it like a pair, and we can ask for the pair. And that's what we're getting. So it's not because it's I or whatever. It's just if you only pass one thing, one argument, you're going to get tuples by default. And then when we go back to being explicit about the two values, then we don't necessarily have to have that be a tuple. We could do a dictionary, right? And do that key value pair that I showed you guys before. So you can do a lot more and be more versatile when you call upon both the index and the value. And I'll show you what I mean. So let's say our I and our v here, but let's say we only want the I, for example. Well, we can do that, and we're only getting the indexes. And instead of the I, let's ask for the v, and we're only getting the values, so we're getting our strings. So you can kind of be explicit about wanting your index and your value, but then ultimately you only have to pull the value, or you only have to pull the index if that's what you want. I would also note that this doesn't even have to be a list comprehension. So we could do a set comprehension as well. and we use the squiggly brackets, and that will return a set for us with our values. Or we could do the key value pair, and that will make it a dictionary comprehension. And you see we've returned a dictionary with our key value pairs. Basically the same thing as before, except that what's being returned is not a list. In this case, what's being returned is a dictionary. And in this case, what's being returned is a set. So a lot of optionality for what you can do if you pass both of the values or ask for both of the values. I'm trying to think what else to show you because I kind of covered everything really fast. But let's say the index doesn't need to necessarily be 0. That's probably worth mentioning. So you could do something like adding +1, similar to a traditional for loop where you might have situations of like +1 errors, things like that. Well, you can be explicit and start the index wherever you like. We could do +10. So you can get a little bit creative about the index, of course. And then the value, of course, you can get creative about as well. So let's say instead of passing a string, we pass like a list. And in this case, we'll just pass some numbers, 23, 66, 55. Okay, so there are values, there's our key value pairs, and you could, of course, modify this value any way you want. So I'll just show you, you could wrap the value around a string, and now we've stringified those integers. So just showing you that, of course, you can modify, do whatever you want with your key value pair. And again, you don't need both either. So you can just return the index or just return the value. And probably worth mentioning as well, it doesn't need to be I and V here. You can name it whatever you want. So you could be explicit and call this the index and the value. Or if you don't want to call it the value, you could call it foo. Really doesn't matter. And then we can pass foo. And you can just be creative, do whatever you want with it. What's important is just the concept of what is Enumerate doing, and it's providing that index. Because if we were not using the index built-in function and we just passed a list here, well, then we would have our I, and we would do something like I for I, and there's just no way to have the index in this case. And this index, these values here, can actually be very important. And so Enumerate is really your gateway to being able to capture and keep track of the index while you are iterating. So in this video, we looked at 2 different ways to use the Enumerate built-in function in a list comprehension. So we know that normally, without Enumerate, when we iterate, we just get our values and we have no way to track the index. And so that's where Enumerate comes in, and it plays a very useful role, probably the only way I'm aware of, where you can really get the index super easily. And now we have our 0, our 1, our 2, and that can come in handy in iterations in a lot of different ways. And by the 2 ways, I meant that you can use the Enumerate function. You see here that I'm only passing that one value, as I mentioned earlier in the video, but you can be more explicit about your index and your value by ensuring that in your loop, you request both items there. And then when it comes around to what you want to retrieve from that list comprehension, well, then you can just be explicit on the left side as well. So in this case, we're getting the same thing, but you really get a lot more optionality when you ask for those 2 values in your for loop. So there are 2 ways to do Enumerate in a list comprehension. Hope this was helpful for you guys. Thanks for watching.